techniques we'll learn for structuring our app better is called Dependency Injection. The name may sound complicated, but the concept is actually pretty simple. Dependency injection gets us a number of benefits, including higher testability, increased reuse, and clearer logic flow. In this episode, we'll see what all the buzzword is about, so that we'll be prepared to apply it to Node Slash. If you've ever heard of dependency injection, or DI, before, there's a good chance what you've seen is really complicated. Injector frameworks and factories and scaring new to the concept developers out of using an important design principle tutorials abound. Aside from university classes and a couple of weeks at a job I had once before, I've never been a Java developer. Perhaps there's something about the Java language that requires that sort of complication, but luckily we're not Java developers here. If I were to write a simple definition of DI, I'd simply say that it is passing to functions the things they need to do their job. Let's look at a simple example that does not use DI. Here we have a function representing a query into a database. It seems reasonable enough. In your module, however you get your DB, you have defined some return value that gives access to the actual database. So when you're running your development server or your production server, you're able to actually put values in a real database. You ship your product to lots of customers, get acquired by Google, and retire sipping real fruit smoothies on a beach in Antigua. I can think of worse things. Except, there was a bug in production. So you write a test to reproduce the problem. You are able to reproduce the error, you write code that fixes the test, you deploy again, and you're back on your way to that beach. Only another bug creeps up and another, and soon you're thinking, maybe I should write some tests first before the bug is discovered in production. And you do. And you write a lot of them, and find out that your test suite suddenly takes 10 plus hours to run, so it isn't of much use in development. You figure out, wow, maybe my tests are slow because save user is actually talking to a database. A local database is kind of fast, but multiply it by your number of tests and suddenly it's slow. And then, wait a second, you say to yourself, I thought unit tests only tested one thing. Isn't a database a third-party API just like the Facebook Graph API is? Yup. But at this point, how would you test your code without actually talking to a real database? Suppose you write a cool in-memory module that has the same interface as your DB. Would you try this? By branching off the environment variable? Yuck. Props on getting the in-memory version, but that if-else is likely to get replicated in many places. And now you've started using a global variable, process. Yes, you'll have that in Node, but now you can't use this code anywhere that doesn't have it. What if another Evented.io JavaScript platform came to be that didn't call it process? What if you're writing an NPM package and you don't want to force your global dependencies on your users, and so forth? This is exactly what DI solves. Let's give more context to our save user function. Suppose it was in its own module like so. So this module just exports a single function, which takes whatever database object you want to use and hands back a save user function that will use that database object through its closure. Closures are coming up next episode. Now you have some top-level script in your development server where you get your real database and then you get your save user function by passing it that database, and then you can go ahead and start the rest of your app with that save user function. So then in your test file, you could do something like this, where you have a test database and it's the same process of setting up that function. And now each of your two environments get the database they should have, and your save user function didn't need to change at all. That's the power of passing it the things it needs to do its job rather than hard coding them. And that's all there is to DI, at least in a dynamic language like JavaScript. It's no magic, no complicated frameworks, just passing things to functions. So what's the downside? You may have noticed that this required extra typing. If you were to compare lines of code, the DI version has more. I consider this a non-issue because when I'm working with the code base, I've not yet encountered the situation where my typing speed was the thing delaying features. Dealing with terribly coupled coat hanger code tends to do that a bit more. This does introduce some extra indirection, and I'll take that as a fair critique. It theoretically could become difficult to figure out exactly what object is getting injected and thus called. In practice, I've only had this be a theoretical issue. Seriously, that's all there is to it. You've seen Angular's dependency injection and thought, shucks, that's complicated. I really don't see the need for it to be, and I've received a great deal of benefit from adapting this technique in my architecture. My apps have become shells into which I can breathe the breath of life through parameter lists. This is not a new concept. This is exactly how our view templates work. Those are just string generating functions, and you're already comfortable not having them instantiate hard-coded objects. DI just makes us consistent in that. We'll be looking at how to apply DI throughout our entire app in episodes to come. The way we've been building Node/ was a good first attempt, but we're going to have some refactoring to do. Until then, happy coding.